Right, so we have done congruence of 2D shapes. We've done triangles and proofs. We've done similarity with lengths. So you should have done that worksheet with the three extension questions at the bottom. And we've also done this bottom bit here, which is proofs of similarity. So if you remember, for similarity, we have all of the angles matching with each other. We have the lengths being a scale factor, or we can have two lengths and an angle in between that match. So the angles match and the lengths are scale factors. Now what we're going to do now is area and volume is going to be combined into one video because they relate quite a lot with each other. So you already know for length, if you have two shapes, you can say that the scale factor in this case happens to be 2. The area, however, goes from 1 to 4. So the scale factor for the area is 4. In this case, you can see the length scale factor is 3. However, the area goes from 1 centimeter squared to 9. Another example here, we've got 1 centimeter square for a 1 by 1 square. In this case, it's 4 by 4 to give you 16. So the length scale factor is 4. The area scale factor, however, is 16. And then from here, you probably spot a pattern. Doesn't matter that I've used a square, I could use any 2D shape as long as they are similar. If the scale factor is k for length, well, then the scale factor for the area will be k squared. Now, looking at volume, if I have this time I've got a 3D cube, I can see that the length goes from 1 to 2. So the scale factor is 2 because I'm multiplying it by 2. So this is a 2 by 2 by 2 cube. This is a 1 by 1 by 1 cube. The volume, however, goes from 1 cube to, well, that's 4 in the front and 4 in the back, so it's 8. In this case, I can see the length goes from 1 to 3. The volume, however, goes from 1 to, well, how many cubes are there? It's going to be 9 times 3, which is 27. And another example here, the scale factor for the length goes from 1 by 1 by 1 to 4 by 4 by 4, so it's 4. And the volume goes to 64. And again, you can generalize this. If the scale factor for the length is k, then the scale factor for the volume will be k. Well, you can see we're cubing the numbers. It's not a coincidence that we're using cubes to show this, but actually, again, I can show this with any 3D shape. If I were to draw a fancy vase and then one that's where the length is 3 times bigger, well, the volume would be 3 cubed times bigger as well. So it doesn't have to be cubes, but cubes are units, the base units that we use. So looking at some examples here, this time we're looking at area. So we have two shapes. You're told that they're similar. The area of P is 10 centimeters squared. Find the area of Q. Well, so for whenever you do a similar shapes question like this, you always work out K, and then you square it or cube it or whatever, or square root or cube root, depending if you're going backwards. So in this case, I know that the scale factor for length, so K is equal to, well, 3 times what is 12? That's going to be 4. So K squared equals 4 squared equals 16. So that means it's going to be 10 times 16, 10 times k squared equals 10 times 16 equals 160 centimeters squared. Another example here, surface area. So it's a 3D shape, but we're still looking at area. That should say area. So the surface area. In this case, the length 14 to 35. I'm going to multiply by 35, divide by 14. Now that should give me 2 over 5. That's wrong. Did it in the wrong way around. 5 over 2, sorry. I can then, that's my k value. So k is equal to 5 over 2. So k squared is equal to 25 over 4. Now, I haven't actually read the full question, but I think I know what I have to do here. Surface area of cylinder R is 40. We're going this way, so we're going in the same direction. So we're still going to multiply 40 by 25 over 2. So that will end up being 20 times 25, which is 500 centimeters squared. That is the surface area. So we're doing area, we're using k squared. Okay, here is a volume question. So you're told that these two shapes are similar, R and S. The volume of R is 50 centimeters cubed. Calculate the volume of S. Okay, first thing we do is find K. So we're going from 6 to 24. This is a nice and easy question. So 24 divided by 6, I can see that this the value of K is going to be 4. K squared is going to be 16. And K cubed is going to be 4 times 4 times 4 is 64. So 50 times 64, which is 3,200 centimeters cubed. Now, looking a couple of more examples here. So shape X is enlarged by a scale factor of 5. So you're told that K is equal to 5. So I can just show you that. The area of shape X is 3 meters squared. What's the area of shape Y? So the scale factor for area is going to be 5 squared, which is 25. So the area of Y is going to be 25 times 3, which is 75. Example 2, shape A is enlarged to form shape B. The surface area of A is 30. So let's put that on there. So surface area of A is 30 centimeters squared. The surface area of B is 120 centimeters squared. If shape A has a length 5 centimeters, now it doesn't say which length is 5, it doesn't really matter. We're just going to put a 5 there. Work out the length of shape B. So we now have to work backwards. We're going to be square rooting and cube rooting at times. So I know that when I multiply 5 by K, I get my answer, which I'm looking for, but I don't know what K is. So I also know that when I multiply 30 by K squared, I get 120 because that's the area. So area times K squared gives me my new area. I rearrange this, so I have that just behind the box here. I rearrange it, so I do 120 divided by 30, which is 40. Square root of, is 4. Square root of 4 is 2. So when you know that, that is your scale factor, which is 2. K is equal to 2. You do 5 times 2, and you get 10. And now just example 3. Shape A is enlarged to form B, has a width 5 and 15. Now we're looking at volume in this case. So we can see the scale factor K, it goes from 5 to 15, so K is 3. The volume goes up by 3 cubed, which is 27. So then you do 20 times 27 is 540. We're just going to do a couple more examples, and then you guys can go off and do your independent work, which will be the final sheet. So have a go with these two. Pause the video. Okay, I'm now going to go through them. Well, I'm going to show you the answers. I don't think I need to explain this much to you because you've done it. Now, harder questions. They're not actually that much harder. We just need to be careful what we're squaring and square rooting. So this time, rather than being told lengths, you're told areas and volumes. So you essentially have to go back and work out K. So solid A is enlarged to form solid B. The surface area of A is 30 and the surface area of B is 270. So essentially that means 30 times K squared gives me 270. You can rearrange that to find K. And then it says the volume of A is 80. Find the volume of B. Well, once you find K, you do 80 times K cubed. Again, the working out is here. You can have a look at that. And example 6, you can have a go if you want to, otherwise I'm going to show you the answers because I think I've done enough examples, hopefully, for this topic. So here are the answers to example 6 if you've had a go. Okay, so we have now got to the point where we've covered all of congruence and similarity. This is the final exercise sheet I want you to do. So it says exercise 1 area volume, exercise 2 area volume. It's actually just one exercise, to be honest. The answers are provided. Do all of those questions, and I am going to start working on the video for the test questions, which I'll have to do again. But, I don't mind. I will see you guys, I don't know when, at some point in the future.